All right, welcome back, guys. Today we are going to learn about 3.1. And as we dive into chapter 3, we're going to transition from strictly organizing data with graphs to looking more at the data we're collecting. Specifically, we're going to be talking about averages and variations in data. What are averages and variations? How can I sum up the data? What is the middle of the data? What is the average piece in the data? And then variations in data is the spread of the data. How consistent is the data? Is it very spread out, or does all the data stay around the same range? Okay, we're going to dive all into that. But first, in 3.1, we're going to do some review over averages, or another term for it, measures of central tendency. Now, I do want you to take notes on this, but please know you've probably seen most of it. So I might be moving through it somewhat quickly. If any of this is new to you, please pause the video and shoot me any questions you may have about the topic so that we can go over it. Okay, let's talk about the mode. The mode is the value that occurs most frequently. I'll move this up here. Value that occurs most frequently. The way I remember it, mode and most. Okay, that's how I remember it. Why do we care about the mode? Well, it is super useful if we want frequency. The example I like to give for where mode is impactful, if I was making a purchasing order for a shoe company and want to know what shoe sizes and styles are ordered most often, right? Because maybe the median shoe size or the average person's shoe size is not what I'm selling most of. Think about basketball shoes or football cleats. If I just look at the average male shoe size and order the most in my purchasing order, if I take the mean of all shoe sizes and find the average, right, that might not be accurate for my purchasing order if I'm selling basketball shoes or football cleats, because the athletes might have larger feet than normal. Therefore, also, if I have a shoe style that's more popular than the others, I'm obviously going to want to order more of those. Plus, the mode is super impactful for frequency. The size of shoe and the style of shoe that are ordered most often is the shoe that I am going to order most in my purchasing order. So the mode would be really good for that situation. Again, mode is the value that occurs most frequently. The other thing you need to know about mode is that mode is unstable, because if I add a piece of data to the set of data, it can change like that. So if I give you an example here, let's say I have a set of 5 pieces of data. You would tell me that the mode is 3. But I add a single piece of data here. Now the mode is either 3 or 9. And if I add 2 more pieces of data, it is now 5. It's constantly changing when you add or take away data. Not that the median and the mean, which we'll get into a second, don't change when you add or subtract data, but they aren't as volatile when you change. So again, the mode is super useful if we want frequency, how often something is happening. The shoe example is a good case for that. And you need to know the mode is not stable. Okay, so let's move on to median. Median is the central value of an ordered distribution. This was when in 4th grade you had all the numbers in a row, and you took them, organized them from least to greatest, and then crossed them off in the middle. If I have 3, 5, 9, 7, 13 is my data set, and I wanted to find the mean, then what I would do is I'd order them from least to greatest, and then I would simply cross off each end till I get to the middle. And then you got that really challenging problem where maybe there was an even set of data values. Let's say we threw 15 in here. And so then what you had to do was not only organize them and cross them off, But when you did that and you got to the middle, then you had to add these two together and divide by 2. So I do 7 plus 9 is 16. Divided by 2 is 8. So my median in this case would be 8, right? That was the extremely difficult problem. You're very familiar with this. So we find it by ordering the data and identifying the middle. But where in stats does this matter? Where does it become important? Well, the key you need to remember about median and what might be new to you is that outliers do not impact the median. Think about it like this. Let's say I have 7 houses on a block. And let's say 6 of them cost $200,000. But one of them, a wealthy CEO maybe, costs $2 million. If you would find the average house price, aka you found the mean of those house prices by adding up the 6 that cost $200,000 and then adding the one that costs $2 million, dividing by however many there are, what you're going to end up with is not an accurate representation about the average cost of a house on that block. Why is it going to be inaccurate? Because it's probably going to fall somewhere around $400,000 or higher. But you can eyeball it and tell me that most of the houses on that block don't cost over $200,000. What am I getting at here? The reason the mean or the average is inaccurate here is because 2 million is an outlier. 2 million is an outlier. Whereas if you found the median, you ordered it, you had 6 $200,000 and then 1 $2 million, immediately that outlier will get ruled out and you'll tell me the median's $200,000. What am I getting at here again? The outlier, when you have outliers, you want to use the median. This is because median cares about the location of the data value, where it falls in that number line least to greatest, rather than the physical value. Mean, on the other hand, cares about the physical amount. Okay, so that's median. Please know it's the middle value, and it is fantastic when we have outliers. Mean, on the other hand, is one of the ones we use most frequently. Mean is the sum of all the entries divided by the number of all entries. It's, if I looked at your average test score, I would probably add up all your test scores and divide by however many of you took the test. When you hear the word average, you probably subconsciously think of mean. And it is great for testing averaging, but as I just gave in the housing example, it can be impacted by outliers. If all of you take a test and you all get between an 80 and a 90, the mean will probably be about 85. If all of you take that same test and get between 80 and 90, but one person gets a 10%, the average is probably going to be maybe in the 70s or the 60s. Again, if there are no outliers, the mean is the way to go. But if there are, we need to go with the median. Okay? Last concept, how do we see the mean in stats? What I'm getting at here is we're going to see some formulas. You see, in stats, we have all types of fancy symbols we use to identify certain things. You will see these on your formula sheet. Again, that's on Schoology right next to, there's a link to it right next to the weekly calendar. Please go access that. If you are ever confused about a formula, you forget a formula, you want to know what a symbol stands for, use that formula sheet. You're going to use it pretty much from chapter 3 on. We don't really touch it in chapter 2 or chapter 1, but chapter 3 and on we definitely do. So how do we see the mean in stats? Well, we see 2 types. You're going to use the symbol with the X with the line over it for talking about the sample mean. Again, it's exactly what it sounds like. When we calculate the mean of a sample, we're going to use the symbol called X bar. Why is it called X bar? Because it's X with a bar over it. Okay? What about when we look at the population mean? The symbol we use for population mean is mu. Okay? It's this curvy looking M. And no, I don't typically write my M's like that, but it is the Greek letter mu, or the Greek letter for M. Again, that's going to be our symbol we use for the population mean. And over time, you need to know these. So please write these down. Look on the formula sheet. You're going to see this on that first page. So after you finish watching this video, take a second and go check out that formula sheet. See if you can find out where X bar is and where mu is. And you can see the formulas for sample mean and population mean. Okay? So that's all we have today for 3.1. Again, if you have any questions, please shoot me an email, let me know. Otherwise, have a great day.